Hey guys, Mr. Bowman here. Today's learning objective is in blue and we are learning to solve quadratic equations. And the key bit of today's objective is we are solving equations which need a bit of simplifying. So before we get into some questions, let's recap the two criteria for solving quadratic equations. One, it must be factorized, and two, it must be equal to 0. And we've focused on the first part about factorizing different types of quadratics. Today, we're actually going to focus on the second part, that's quadratics that aren't equal to 0. And I'll show you what I mean by that with our first example. So example number 1, let's say we got x squared plus 10x plus 21. Let's say that there comes to negative 3. So if we look at our equation and reconcile that to our two criteria, you'll see that neither of these criteria are met. It's not factorized and it's not equal to 0 because of that minus 3. So what we need to do here is we need to make it equal to 0. Once it's equal to 0, we can go ahead and factorize. So our first issue here is that minus 3. We need that to be a 0. And to get rid of that minus 3, we're actually going to add 3. And these here combined, minus 3 plus 3, that comes to 0. Which would then meet that criteria we're looking at here. We've added 3 there, we've got to have to add 3 on the other side. We then go ahead and simplify. That's going to become x squared plus 10x plus 24. That there will be equal to 0. Once we've done that, we've got the first criteria met. We can go ahead and factorize. So we've got to think what two numbers multiply to 24 and add to 10. Hopefully you're thinking 6 and 4. So we're going to put that in our brackets, x plus 6, x plus 4 equals 0. We're then going to split off into two separate equations. And this is where it's going to get a bit easier. X plus 6 must be equal to 0. X plus 4 must be equal to 0. Our first answer, minus 6 minus 6. So x1 equals negative 6. And then minus 4 minus 4. The second answer of x will be equal to negative 4. So hopefully that first example makes sense, just showing us a bit of simplifying is needed to make sure one of the sides is equal to 0. So let's get a bit more complicated. Let's have a look at our second example. And this one here, it is going to get a bit messy. So we've got x plus 3, x plus 4. That there is going to be equal to x plus 7. So this one's a bit misleading because it already looks factorized, but it's not actually because this x plus 7 isn't considered in that bracket. So it's actually neither equal to 0 or factorized. So what we're going to do, just to see what we've got, let's expand this bracket here. So it's going to be x squared plus 4x, and then we do the bottom rainbows, plus 3x, and then we've got plus 12. And that there will be equal to x plus 7. Apologies about the bad handwriting with 12. We're then just going to simplify x squared. That comes to 7x plus 12 equals x plus 7. We then, similar to the previous equation, we've got some stuff on the left-hand side which we need to get rid of. So right-hand side. So we're going to take away that x, take away x, take away x. We're then going to also take away the 7 at the same step. Take away 7, take away 7. And when we simplify that, x squared hasn't changed. We do have plus 6x. We do have plus 5. And that there is equal to 0. We now need to think what number adds to 6 and multiplies to 5. Hopefully you're thinking 1 and 5. That's going to give us x plus 1, x plus 5. They multiply together to get 0. We then split off into our two equations. X plus 1 must be equal to 0, minus 1, which means our first answer for x, oops, I've written negative 7, but I definitely meant negative 1. We can then do the same for the second portion. X plus 5 equals 0, minus 5, x2 equals minus 5. So there's our second equation. These ones here are fairly straightforward, reason being we're dealing with equations that are just x squared. Now what I'm going to do is I'm going to pause the video, I'm going to clear off our first two examples, and we're going to go through some harder questions where there is a number or a letter in front of that x. Okay, our screen is cleared. Let's have a look at our third example. And we're just going to slowly ramp up in terms of difficulty. So example number 3. So let's say we've got 2m squared plus 6m plus 2, and that equals to m plus 5. So what makes this question trickier is there is going to be a 2 in front of that m squared, which means that factorizing process is going to be a bit annoying. But before we do that, we actually need to meet the second criteria. We've got to make sure that's equal to that's equal to 0, which means we need to get rid of the m, we need to get rid of the 5. So let's get rid of the m. We're going to go minus m. We're also going to do minus 5 minus 5. So that means 2m squared plus 5m. That's going to be equal, or written m there, but that's meant to be 5 before, wasn't it? Minus 3. That there's equal to 0. We're now going to factorize, so we're going to go 2 times 3, or actually negative 3, which gets us to negative 6. So we've got to think what numbers multiply to negative 6 but add to 5. And I'm thinking 6 and negative 1. So that means we're going to split the 5m into 6m and minus 1m. So we've got 2m squared minus or plus 6m minus m minus 3. That there's equal to 0. And we're using that grouping method. We factorize the first bit. They've got a 2m in common, which leaves m plus 3 left over. We then go ahead, we look at that second bit. They've got a minus 1 in common, which leaves m plus 3 as well. That equals 0. We can see we've got that same common bracket. We haven't made any silly mistakes, so let's put that common bracket down, m plus 3. And we know the second bracket will be the 2m and the minus 1, 2m minus 1. They combine to get 0. And like that, we've got our double bracket. We can go ahead and simplify. Or, sorry, not simplify, but split. There's the first equation. If m plus 3 equals 0, we've got an answer. So we're going to go minus 3, minus 3. And there's our first answer of m. And we're going to repeat the same if 2m minus 1 equals 0. Plus 1 plus 1. So that's 2m equals 1. And then we've got divide by 2, divide by 2. m2 equals 1 half. There's our two answers for that messy looking equation. And we've now got our final step or final question here. Or not final one, but we've got one more after this. So we've now got, let's say, example number 4. We've got 2x minus 1. That is all squared, and that there is equal to 4. And first step here, let's change that double bracket. Well, it looks like a single bracket, but it's actually a hidden double bracket, isn't it? Let's expand that bracket. That's going to be 4x squared minus 2x plus 1 equals 4. Simplify that nonsense. So we've got 4x squared minus 4x plus 1 equals 4. And we're now going to try to meet that 0 criteria by doing minus 4 minus 4. So that there is going to be 4x squared minus 4x minus 3 equals 0. We're then going to have a look at our factorizing. So we're going to use the grouping method. So we're going to multiply the 4 and the negative 3 to get negative 12. So we need to think what numbers multiply to negative 12 but add to 4. And I'm thinking negative 6 and positive 2. So that there is going to be 4x squared minus 6x plus 2x minus 3. All of that comes to 0. Factorize the first bit for me. We've got 2x minus 3. And no factors in common for the second group. So we're going to put in our plus 1. 2x minus 3. That there's equal to 0. So our factorize when we get it. There's our common bracket, 2x minus 3. And the leftover bits, 2x plus 1. That there comes to 0. We go ahead, split and solve. 2x minus 3 equals 0, which means 2x equals positive 3, which means our first answer, 3 over 2. And our second answer, well, 2x plus 1 equals 0, so that's 2x equals 1, or negative 1. X equals negative 1 over 2. And that's our second answer for that. So guys, hopefully those questions make a bit more sense, and we're just linking some harder and harder simplifying concepts to our quadratics before we can go ahead and solve it. And now what I'm going to do is the very final question. I'm going to pause the video yet again, and we're going to do the messiest looking question we have, but hopefully we can become more and more confident with it. Guys, we're back at our final example, example number 5. And this example is a little bit different. So let's say we've got 3 over 2x minus 1. That there is equal to x minus 3. And what makes this example different and what makes this skill quite interesting when you get to our harder questions is we've now got fractions. And I just want to emphasize, when you're dealing with fractions and quadratics, your normal fraction rules, they still apply. So don't forget these. So I can't go over every type of question on the video, but just a reminder, normal fraction rules apply. And in this case here, if you had a fraction here, you would get rid of that denominator, which is currently division, by timesing 2x minus 1. And then we do that to the other side as well. So that means 3 is going to be equal to x minus 3 to x minus 1. We did a timesing there. You may need to do your crisscross smiley face method. You may need to do top times top, bottom times bottom. You may need to do your switch if you're dealing with division. But your same fractions rules apply. I can't emphasize that enough. But then let's expand that other side there. So that's going to become 2x squared minus x minus 6x plus 3. And that there becomes 2x squared minus 7x plus 3. We're then going to get rid of that 3 by doing minus 3 minus 3. So 0 equals 2x squared minus 7x. We've now got that equal to 0. So we'll go ahead and factorize. And this here, notice there's no number at the end. So that means it's actually going to be a single bracket factorizing, which is still a quadratic, and there's nothing wrong with that. So that's going to become x, 2x minus 7. There's our first bit. So our first answer is solved straight away. If x is equal to 0, that equation is true. And our second split, 2x minus 7 equals 0. So we're going to go plus 7 plus 7. 2x equals 7. Divide by 2, divide by 2. Our second answer of x is equal to 7 over 2. So guys, slightly longer video than I've been trying to do, but hopefully we ran through enough scenarios which will give us a bit of insight in how to solve quadratics, which need a bit of simplifying. Another reminder, got it there on the right, your normal fraction rules apply. Don't get scared when you got messy fractions. Just go ahead, try to simplify those fractions, and then you'll be able to get into these harder questions as well. Thanks so much for watching, guys. Let's get into heaps and heaps of practice now.